Hello and welcome to the Environmental Test and Design webinar. RFQ, now what? MIL Standard 810, Understanding Your Requirements for Military Equipment. My name is Belinda Stachukevich and I'm the editor of Environmental Test and Design. Environmental Test and Design, which launched in 2009, specializes in the interrelationship between electronic systems and devices and their environments. This webinar is presented by Steve Ferguson, Executive Vice President of Washington Laboratories. Steve has worked in the compliance test arena for over 35 years at test labs and manufacturing companies, designing products, developing procedures, and performing tests. He presents various courses on EMI and EMC compliance. He's an INARTE certified EMC engineer and administers the INARTE approved Washington Laboratories Testing Center. This webinar today will be interactive. You'll be able to ask questions and answer polls, and we encourage you to participate. Take a look at the GoToWebinar navigation pane. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand to ask a question or report an issue, click the hand icon. We'll present the topic for 45 minutes, followed by a 15-minute question and answer session. Before we begin, we have a poll question for our audience. Attendees, please answer the following question. Do compliance engineers, technicians work on proposals at your company? Yes, fully integrated into proposal team. Yes, provide analysis of requirements. Yes, limited to specific questions. Or no, not consulted during proposal preparation. We'll give you a few seconds to answer. And we have answers in pretty much every category, pretty even across the board.
Well, it's interesting. One of the things that I've found over years of working with it, the more involved the design compliance people are, the design things for compliance, the test group, those very aware of what these requirements mean as far as products. They support the design and get this proposal right, because as you'll see during my discussion today, frequently the proposal is grossly inadequate in defining what you need to do. So these experienced people really bring a lot to the table as far as the proposal preparation, so we don't accidentally fall into the yes, we can do that when it's not feasible for anybody to do it. And then you have to discuss it at a later time and get a deviation to the winning bid if you win. So sometimes that's good. I've also discovered that these questions about an experienced person can be the winning topic. If the experienced person brings a question on board that no other bidder even imagines, then there's an awareness from the vendor that maybe this design team has the wherewithal to understand the thing better than most. So integration of these people is not a bad thing, and if you're the person that does the compliance work, maybe you need to talk to the supervisors about becoming integrated with proposals. It can be very supportive and educational, and you understand what's coming should you win. Just my 2 cents worth, shall we say. With that, I'm going to get started here. What is MIL Standard 810? Well, the title says Test Method Standard. We all understand that, but the reality is it goes a lot deeper. From a program management guide where the topics enter into the figuring out what's needed, to the engineering process to determine the exacting requirements, it discusses methods and options for tailoring, and almost every program is tailorable to try to get to reality. Engineering guidance, how do you get to that system and the tailoring? What makes sense? Understanding why it says to evaluate one item or another helps us all decide, well, the better way to approach this would be to X, do something slightly different. And it needs to be proposed in a way to where it makes sense, well thought out, well conceived. This is just blindly applying tests. The basic procedures in handling of situations are always discussed, for instance, interruptions during the test, what happens, etc. But the idea is it gives the basics only, not the details. you need to work out the real details in the program from contract all the way through to development and the reporting phase. Provide some basic test levels, again, not exacting, except in some cases are very, very precise from field data, where this data is very specific in its nature. It also talks about climatic conditions for the worldwide applications, gives you what the weather is like no matter where you deploy. So if you're trying to build a one-size-fits-all, you need this kind of information to support your development program. It's all in there. Sometimes it's very difficult to extract it. It's a very lengthy document. Almost none of us have ever time to read it, just like the Affordable Care Act didn't get read. But the idea is that we need to look at it as far as specifics go. Read it and know where to find the information. Don't try to memorize it, because working out of memory will get an error because updates happen frequently. So don't get in the habit of thinking you've memorized all the necessary things, because suddenly you'll be one revision off. The test methods are defined out there, and 810G came out a couple of years ago, and it added several tests noted down at the bottom and highlighted. And these tests are very much time specific, especially the time waveform, the multi-exciter work. It's not a generic function. It's a very specific thing where you duplicate a waveform that's presented as part of the overall program. Now, where does that waveform come from? Well, measured data. You're building something to go on an item that has a history. It's been around a long time. Or it's like its brother. So the idea is that these waveforms have been recorded, and those specific things are so important that we get it right. That information can be used to develop a shock pulse, a vibration, or whatever. These things become very defined. Whereas most of the items are very generic in nature, to where you give a general guidance and understand how to get there. So throughout this, remember you have to develop the exacting requirements. Some things are very defined, but usually you end up tailoring most of the testing, especially those things that are done routinely. The more specific an item is to a particular application, the more data and the more specific it should be defined. These things are available there. When we start out in the part 1 of the 810, we have environmental tasks. These things are, as shown there, the different elements that go into developing a program, from the engineering management plan to the life cycle environment profile. What's it going to be faced with? The operating environment. Where's it going? What kind of issues are to be expected? And the environmental issues criteria list. Those things that are very specific to the product. From those elements, a detailed environmental test plan needs to be developed. The test plan can be very specific. Now remember, a plan may not necessarily be the procedure. What's the difference between a plan and a procedure? Well, a plan tends to define what you're going to do, how you're going to approach resolving a topic. Am I going to test it? Am I going to analyze it? Am I going to replicate it? Do I have intermediate things that may be necessary to develop parts that goes to the overall system? Where a procedure gives a step-by-step activity, that I'm going to put this on table X and shake it at profile Y for Z minutes, etc. Then the test report is a kind of a detailed thing. Now, these topics, 405 and 406, get into the meat of 810, the real detail work. And these plans, and by the way, the development of the plan is the subject for the next issue of this seminar. I've got 4 parts defined, and this is the opening one. So procedure development will be the main topic in the following episode. And the environmental report. Clearly, most reports don't have much information. It's kind of like, I did a rain test, here's the answer. Well, that doesn't tell you how you did it, problems you ran into. Did you elevate the temperature? Did you do what? Did you measure the drip rate? Did you measure what? The idea is that this documentation should support a repeat even if the test had flaws, but it should be able to be repeated in the future. Having that detail is very difficult. What kind of wire did you use to connect it for operational testing? Because a subsequent test could use something different where it might leak water and not perform correctly. Change the operating characteristics of the device because of moisture and etc. So getting your environmental conditions right, from the laboratory temperatures and humidities to various conditions, need to appear in the test report. This is not something to be considered lightly. Development of a good report or plan, procedure, template is very important for the laboratory to have, so they're not incurring questions that go on and on and on. Getting a good layout is good. Is it difficult? By all means. You have to collect the data, you've got to document it. But the idea is the quality of that document is something to be considered, because at the end of the day, that's what's in the customer's hands. And the quality of that document and the feedback they get from their users says, oh, I want to use that lab again because they did a good thing for me. So doing a good job here helps everyone. And by the way, we all improve every day in preparing documents. The Environmental Engineering Management Plan, this Task 401, that's defined in the system, is to integrate the environmental effects consideration into the system plan. So when we start looking at the overall system development, you're building a truck, or whatever, a military vehicle of some kind, that's where the environmental considerations need to be addressed. What does this truck require? Is it going to go underwater and do fording, or is it going to be on the desert? Is it always in a cold environment? Can it be deployed anywhere? Does it have to fit on a city street? Things of this nature get into the overall considerations. This comes into being. And these considerations typically get brought into your program for the components, the pieces that go into the truck, from the communication systems to recording devices to weapons systems. All these things are there. This program should identify what it takes to do the other tasks. Other tasks meaning the integration, the lifecycle development, the testing, the evaluations, the analyses, all these things. How much manpower is involved? Boy, is that a tough one. If I'm building a truck and I've got to consider every system, how many days or man hours or locations to get involved in the test program? Financial considerations. We're always bidding jobs and putting all these various tests into the proposals and trying to integrate these things. So the financial aspects come into being. How much is it going to cost to get all of the testing done? And we might look at this narrow scope, this very focused environmental item. But we start integrating that with electromagnetics and power quality and et cetera of evaluations that come into being. And the overall life cycle financial and manpower requirements could be pretty good. Timing and milestones. How many pieces of equipment do I need to run through the test to meet a timing milestone? It's not likely that I'm going to get one truck and run it through every test in a sequence that makes sense without harming other tests, influencing the other items. So the idea is we typically have several pieces to go through the overall program. Who decides? The contacts, the lines of communication. Who do you, as your test house, send information to? Typically just your customer. Does your customer put you directly in line as being your agent, or you're dealing with the government directly on qualifying the product? In some cases that can be true. But these lines of communication and contacts need to be developed during this. Now normally this is the procurement office lines of communication, not the development people, not the contractors people, how they do that. But if the contractor is using multiple subcontractors, Why would they not establish these contacts and lines of communications with their subcontractors? Remember, you got to integrate it and make it work. So all of the pieces have to fit together and come together at the appropriate time. Identify alternatives to testing during this process. Can modeling give you all the answers? Is the modeling system good enough? Can it do this? Simulation. Do I have tools that will do simulation and or analyses that will give you the answer without subjecting the item to test? We're always developing better modeling tools, and quite frankly in the environmental world, especially in the dynamic testing area, well, I should say climatic too, the thermal modeling is getting very, very good. Where the gaps are is input data. Do we put in all the parameters that's needed for the simulation software, the analysis software to do a good job? The answer is we may or may not. And if it is, we suddenly realize that if we fudge this a little bit, the simulation gives us the answer we're looking for. Let us not get into that mode. Let's get the answer that is based on what we know. Don't try to influence the answer with parameters. You have to deal with it that way, or you end up with a problem that, based on design, that doesn't support it. The Environmental Test and Evaluation Master Plan. This is that test 402, 403, 404 element, this overall thing, where it gets the life cycle profile. Identifies events and conditions that the material will experience. It's kind of like the vehicle that has to go through the salt water to get to the beach from a drop-off point through this. Natural and induced environments. Do you have to live outdoors, and are you in an acid rain situation where sulfur dioxide fogging would be a test that you should consider, not just salt fog? It's not in the standard. It's not there, but you have to live through it. Are you exposed to that natural environment? Nothing says that our life cycle plan can't bring new elements that are not necessarily in the standard. You can bring them into being to do the things. Any packaging considerations. How are we going to handle this thing? From the truck and how it's transported to the individual compartments, the pieces that are mounted, and getting the goods to the integration point where the truck is built. Platform integration. How do I piece these things together in the environment? Am I shock mounting it properly? Did I consider those things? Do I have a piece of equipment that gets put on a shock mounted platform within the vehicle? Don't know. Those are questions that need to come in. Because the testing suddenly becomes different when I integrate test fixtures and jigs. Exposure time and cycles and durations. Quite frankly, if you choose the non-tailored method, the suggested times can be pretty exhaustive. Testing could go on for several months versus an aggressive program to identify the problem. Considerations for any natural limitations need to be being. Almost all of us that have been in an environmental lab or looked at a proposal have seen this request for explosive atmosphere testing at 70,000 feet. And we know there's no air to support burning or explosion. So above 40,000 makes no sense whatsoever for that environment. Or having high humidity at minus 40 degrees. Doesn't exist in the real world. There's a natural limitation. So asking for tests, although we may be able to artificially make it happen, it's not a real test. And the real test says, now what if it has an issue? Well, then I have an obligation to fix it. So we're designing solutions for problems that don't exist because we can artificially simulate. Operational environment documentation. This should be part of that master plan that identifies where these things are going, how it's got to work. Is it in a closed environment on a flight line where you go out and open the airplane and you've got to step into the sauna and expect everything to turn on and operate in a huge environment? Or do you allow it to get airflow and cool down to reasonable before you have to fly it? If I've got to take off right away, that thing's got to operate at some pretty extremes. So suddenly it makes the requirement a little bit above the normal, shall we say. How am I going to collect data that isn't currently available? That, just as the example I just gave, the airplane sitting out on a hot flight line in southern Florida. It's a huge temperature box with humidity beyond belief, and I don't have good data on that. Do I send data collections out to the airplane and live through the summer? Not typically. A lot of data is there, but sometimes you may have to get specific. And the environmental issues, those specific things for the stress type. Do I have an extraordinary vibration profile? Do I have to ship it by truck for long distances where the exposure for test might be extreme? Is it always packaged when it's moved? These things need to come into consideration and be evaluated. How do you get a requirement? Well, the contract, typically, you've got this thing, contract says compliance with 810 requirements. Okay? By the way, it didn't tell you revision G, so how do you know G is applicable versus F or some other predecessor? Well, unless it states something differently, the standard that's in effect at contract release date becomes the right one. So if a contract was released for proposal today, then G would be the default. Okay? Somewhere in your response you should say that. So if H comes out tomorrow, you say, well, I was bidding to G. You understand that. The contract needs to state the compliance with requirements and pass it down to the functioning equipment. So I've got the system requirement, and those system requirements should say, well, for the components, I've got to live through the same thing. Flow downs might come into place where the requirements of the system get imposed for each of the subsystems, so that temperature extremes, etc. Also, considering functioning equipment should consider the protections offered by the platform. If you've got a lighting system that's for map reading inside a vehicle, it's not going to get rained on inside the vehicle unless it's an open top somehow. The idea is do the right tests for whatever. Is it going to get sand and dust? Sand? Probably. Dust? Possibly. But is it going to be blowing sand, or is it in a protected environment? Do the right thing. So there's no reason to fix a blowing sand problem if it's always going to be protected in the vehicle. They also have something that they don't really say in A10 called a non-developmental item. Those commercial items that are privately developed but qualified for military applications. The purchasers sometimes impose these military compliance. They want to buy a crane that's off the shelf. Nothing special about this crane, just buy it off the shelf. But the contract pulls in 810, and suddenly there are specific issues. Unless somebody makes sense out of it and says, we do not want to redesign this thing for a military application. Our application is a routine use in the military installations. It didn't have to require special compliance issues. Because when we look at these compliance issues, at a bare minimum, we're going to pay the cost of evaluate and test throughout pricing of individual items purchased. So be aware of imposed requirements. Look at it. Does it make sense to impose these requirements? Linda, I have a poll question here.
Okay. An item operates from 115 VAC or 230 VAC at 50 Hertz, 60 Hertz, or 400 Hertz. What is the worst case mode for testing? 115 VAC, 400 Hertz, 115 VAC, 50 Hertz, 230 VAC, 400 Hertz, or 230 VAC, 50 Hertz. We'll give you a few seconds to answer. We have some answers coming in, and about 75% said C. Back to you, Steve.
75% said C. Well, I hate to break the bubble for that many people, but you don't know. There's no way to determine what's the worst case, because 115 volt could draw more current, and with current you have heating that can be a problem. 230 could have the voltage available for a fixed impedance, so therefore more current would flow, causing heating. We could have more of a load demand for motors at 115.50 because I'm not producing the power or the effective power to drive those kind of things. So we don't know enough about the system based on this generic question to know exactly. We may have to run multiple things to determine the worst case, especially in the climatic world where we have temperature involvements and things like that. So we can't just blindly pick one and say that's going to be it without understanding the circuitry a little bit. So let's not step into that pit. It looks like 23400 would be potentially the worst case, but it may not be. Thank you. And with that, the statement of work. Most all contracts come with this statement of work. I need you to build me an X vehicle and paint it green, or paint it camouflage brown, whatever they want to do with that. Put in various parameters for the environmental test. What you have on the screen is a statement of work that I received a while back, and they wanted these environmental things to happen. Now this is the summation of the details I got from about 24 pages of data where it sparsely gave information. But this I gleaned out through all of these areas, searching for the few tidbits that I needed to do to understand my test program. High temperatures, some temperatures for operating and storage were done, low temperatures, etc. The humidity, they even went to the point to say they wanted an aggravated 10-day test. Okay? Without those aggravated 10-day tests, it's hard to decide whether I want cyclic or not. Low pressure, they had to operate at 15,000 feet and withstand 40,000 feet. Immersion, a non-operational test for immersion, vibration, etc. You can read these things, but the idea was that they gave a pretty fair amount of detail into how they wanted to do this. Notice immersion is non-operating, but rain is an operational thing. So you don't have to function during the immersion part of it, but in rain you had to. Why? Well, because the connectors weren't sealed. Okay? They're water resistant, they've got a rubber boot, but they're not sealed for the immersion, so the idea was that they'd specified a connector that couldn't make it. The idea is that if they do that, you have some outs. But is anything missing from those things? Well, between the statement of work and references, there's sufficient information to, is there sufficient information to assess it? Modes of operation. Okay. Do I need to test at 230-400 and 115-400 based on how it operates? How long is the temperature exposure? They gave me a 10-day aggravated test for humidity, but they never told me how long the temperature needed to be. Is it a standard 7-day non-operational, 3-day operational for hot, and cold for running, I think it's 4 hours operational? How long is the stabilization period? How do I determine stabilization? A lot of times it says, well, put something on the devices inside. Well, since it's got a pass immersion test, obviously I can't go opening the thing up and putting pieces inside it that will break the seals. Altitude exposure, does it have to operate at altitude? How long? Because now I've got a temperature difference going on, and because of the air being thinner, shall we say, I may not be able to offload heat so easily. So do I need to have an extended period for operational tests because of the altitude? How about temperatures at altitude? Do I need to elevate them, keep them cold? You don't have that defined in there. The immersion. Immersion is usually called for preheating the device. So if it's exposed out in the open sunlight, it gets very hot and then it goes underwater for the forwarding process. How much above the water temperature should the testing be? So we need to get a preheat defined. Rain, also a preheat issue. And how many samples? In our example, they provided how many samples would be tested. They put 10 places into the test, 10 pieces of equipment, with specific tests defined for each one. This came from the government entity. I've had this very same thing kind of come in from a contractor. The contractor says, here's the sample number 1 and do these tests, and sample number 2, do these tests. It can be done to avoid testing things where problems are. I ran across this because they had a gasket sealing problem, so the immersion test would pass unless the gasket had been heated. After heating, the gasket retained the set and leaked. So they set up a test program where the immersion test was never done on a test item that had ever seen any elevated temperature. Well, that's just conning the system. All it does is get you recalls and warranty work, and your supplier of your paycheck goes out of business because they can't afford to make products that have to be recalled, warranty fixed, or bankrupt because they can't afford to. So you're not doing any favors when you avoid the obvious. However, in the government's look at it, they say this is the life cycle system. So they told us which order to do things and which samples. So they provided it from the contractor's perspective, not from the vendor's perspective. What do we do about this missing information? That you're in the proposal phase. Remember, you're making a bid. Do I need to ask the government, how long do I expose the temperature? Well, a 1-day test at high temperature versus 10-day test at high temperatures will affect the pricing, obviously. Okay? And that affects your bid. Some people look at this as the approach says, I'm always going to ask because I can't afford to get it wrong. The other side of the coin is I don't ask and propose the best case so I win the job, and then I will discuss it later. Sometimes you win those discussions, sometimes you don't. But at best you come out not looking well. A lot of people take the solid approach is I'm going to make an assumption and document my assumption clearly in the proposal. Well, it's usually not wrong. Okay? But if it's a huge effect, you may want to ask the question. But remember, if you ask the question, the answer goes to your competitors just like you. Everybody gets the information equally for the proposal. So if you have an advantage because you're aware, you're not going to expose this. And some people do, or they believe they have the example. For non-developmental items, those things that you're self-inflicting, what requirements would apply? Are you developing a replacement for an existing system? Okay, you've got a windshield wiper motor going in this vehicle, and you're replacing the one that was already there. Do they have updated requirements? Typically, the requirements go to an old standard. If that vehicle was qualified using MIL 810E, you may have E imposed to make it consistent with the existing equipment and the profile. So sometimes you have to deal with the older standards because of the integration and qualification process. If you're building something from scratch, how do you determine what's needed? Is your product widely used? You deploy it everywhere. Is it just used in desert environments? Is it just used in the Arctic North? Is it always used inside a building? Is it ever used on mobile applications? These things come into your decision points. And can you look at the future market? Well, it's not on a vehicle use or mobile application today because I've got to have a big old pump that won't move. Well, what's the other application? I've developed a new technology pump, and you're ready to go because you've already got a qualified product. It's a market challenge because you're instilling cost in development of your product and making it perform to these levels when you may never see the application. So look at this. What tests would you do if it was a facility application only? Something that always goes in a building and is never used in a mobile environment. 810 is really focused around mobility, being on the move, being something in a vehicle, being something in an airplane, being something on a ship. So the facilities are moving applications versus a ground facility that just sits there. Aside from occasional earthquake or tornado or something like that, you don't see these heavy requirements. So if you're only going to be in the facility location, the tailoring of what things might be appropriate really gets exhaustive to get down to virtually not much. Body-worn equipment. If I'm carrying this thing around, it's something with me, you got to deal with the people dropping it and things like that, but you don't have the constant vibration of a truck jarring it. You do have movement from the person wearing it and an occasional shock and drop. But it's not the same environment when it's body-worn. So when you look at these developmental items, consider what your goal is. What is this test really trying to tell you? Is it giving you packaging requirements? Is it various kind of things? So understanding the goal really helps you develop the right kind of product. When I integrate government furnished equipment, the GFE, shall we say, well, that's always somewhat robust at best. Let's say that this vehicle that you're bidding on tells you that you've got to use the communication system that incorporates the modern technology 6136 tunable radio. Basically, the government told you the radio to use. They gave you a specific model and manufacturer to integrate into this system. That, even though you may be buying it to integrate into your system for delivery, the government told you what to do exactly. So then what happens with compliance issues? This modern technology, when it gets warm, it goes off frequency. It doesn't do the right frequency. It's not stable. How do you deal with those kinds of issues? Well, in some cases, the standards tell you how to deal with it. This is not the case in 810. To tell you if it's government furnished, then what it is what it is, and nothing else has to be any better. So if this compliance issue is provided by the communication system or the government furnished or defined communication system, you may have some things you can do here. You may need to resolve it for the overall approval, but you can typically get funded for that work once you identify and clearly show that it was GFE that caused the problem. You can always go for that instead of absorbing the costs on your own. Now, this commercial item is what's called out, so it's got to be the same. Here's the issue that it failed. Okay, the modern tech will say that the testing was improper. Well, naturally, they believe it's right, so you guys changed the temperature too rapidly, or the humidity was wrong, or something was wrong with your temperature test causing instability. The test lab will push back and say, we did it by the book, by the standard, by the procedure. Your recourse is the procuring agency approved the procedure. Okay? So if the procedure truly was followed, it is correct and the noncompliance is real. Okay? Then the round two begins. Your integration caused a problem. When you put this thing in, it said that they were supposed to have a cooling fan at least 25 CFM of air movement, and you didn't put one in. Why? What makes you believe that you got that information about the document? Who owns the problem? And by the way, this urinary battle, shall we say, goes back and forth forever. You'll continue this till you get blue in the face and realize, well, because you don't have it in your file didn't mean they didn't send it. So the arguments and the finger pointing stays valid for a long period of time, and nobody really wins on this battle. So be very clear about things. When you're providing it, understand the situation. It's always going to be a problem. And by the way, I speak to this from experience because I've been there when we didn't define it well. We didn't do this. We didn't get records of sending or receiving documents. These things were no confirmations. How do you get that? Well, you may send a document and ask in another distribution channel, confirm receipt. Okay? If they didn't receive it, send it again. If you don't get the confirmation, you've got to get that confirmation back. So this documentation sometimes becomes very important. 95% of the time, you don't have issues. It's that 5% that kills you. Okay? So keep your documentation, keep your records, save the files. We're in an electronic world. We don't have the paper to back us up. So these file saving things and dates of when things happen. A journal, a database, Who shot John? You know, what day did he pull the trigger? Did the bullet get there immediately? All these things that need to be considered in your journal. A project should always have the journal going with everyone that deals with the communication making those entries as they occur. Keep the records. The bottom line is a caution. Make sure you understand the responsibility and how it affects your proposal and design, and are you on the hook for it? If they, in that statement of work, says use the technology 6136, you're going to need to say back in your response to proposal or your proposal that you're considering that to be government furnished and any issues are being dealt with on however you define it. Okay? You need to make statements of that effect in your proposal. Another poll question, Belinda.
Okay, have another question for our attendees. What methods are used to determine temperature stabilization? Thermocouple on the test sample, time allowance, not necessary for cyclic tests, or all the above? We'll give you a few seconds. And we're getting some answers in. And it looks like slight majority said all of the above.
Well, it should be a good majority because all of these things are used. In our discussion today, we kind of said that the thermocouple wasn't one of the feasible things except on the outside. And to get stability, I need to know what's going on inside. Since it had an immersion issue, thermocouple wasn't going to be one of the allowed. So I may need to consider the mass of the device, big pieces inside that can absorb heat or retain heat, and allow them to overcome that, give them time. And cyclic tests usually don't have that issue. They say, I'm going to expose the outside for this kind of up and down temperatures over a long period of time. And stabilization comes with what would happen in the natural environment that constituted development of the cycle. So all of the above is clearly a decent statement here. You try targets for various things, but you may not necessarily need to get to any of the specific ones, but you do need to consider something. A successful proposal. You put it together, you won. Now you've got to start looking at things you have to do. I always consider a design guide, you know, because I've been involved in the manufacturer's world before I came into this arena, where I headed the test group. And the engineering staff needs to have guidance. They need to say you've got to get rid of heat. The mechanical engineer needs to be aware of what these requirements are. Do I have to operate in a 60-degree environment? Am I allowed to operate in a 60-degree environment? Let's take that as consideration. We've got a 60-degree environment, and yet this item can be contacted by the person. Are they allowed, for safety reasons, to be exposed to having to have to touch 60 degrees centigrade? The answer is not normally. Okay? People do it, but they shouldn't have to do it. They shouldn't be faced with the accidental burning that's going to come from exposure or contact with those kind of temperatures. So the idea is that if you've got other requirements like safety or things like that, your thermal things may get affected by what the other requirements are. So if I've got super temperatures, I may have to prevent exposure or contact. And that adds another element of getting rid of the heat. So the design guide needs to be pulling all of these compliance standards, looking at the overall program, and determining how to approach a design that considers more than just one element. The EMC person, the electromagnetic environment kind of people, might need to control RF, and so they put a power filter in it, and you as the power quality engineer realize that the filter has to consider 400 hertz as well as 60 in order to be safe, so I don't get excessive leakage currents. This design guide needs to be pulled together. Okay? Who does it? Well, in our case, the company I was with, we did a design guide through the test and integration group. Sometimes it's the engineering department where the head of the engineering department pulls this together and says, okay, you've got to control all of these things. That staff for the engineer has got mechanical people at his disposal, electrical, power, audio, video, RF, all the various disciplines in engineering that have to deal with these kind of problems, and access to the contract support that they get if they don't have it on staff. A lot of designers call in contract support to help them with the development phases. You need to get started right away on a procedure development. Something needs to happen right away so you can understand where I'm going to early and get this schedule established. Having a good procedure well ahead and approved of the test time is important. Too often times we get exposed to, ooh, I've got a requirement to deliver a procedure and I got a test next week. It's too short. Nothing's going to happen that quick. You'll end up with a haphazard program at best, but we oftentimes don't address it until it's late. And that's the first time it surfaces as something we've got to do. Establish a good test program and how to get to the test. A good design guide, even if you're not getting paid for it, okay? And sometimes contracts call for you to prepare the design guide. Even if it's not part of what you're bidding, it's a good thing within your company, because when you go into the test that you're already late for, you may be successful if it's properly implemented. On the next episode of this series, we're going to explore the test procedure preparation details. What do I have to consider in my preparation of a test procedure? From configuring the unit to getting the test article built to escape clauses. You name it, we're going to look at this. When I look at the overall test program, I've also got to consider some intermediate tests for critical elements. For instance, I may have this temperature stability problem or frequency stability problem over temperature, and a clock circuit could be discovered during qualification tests. Do you consider environmental stress screening tests as an engineering model? Not to say that it's production, keep it stable. It's development of failure modes. Do I push it way past where I need to? Am I looking at temperatures and vibration together, and am I adjusting each one for various steps to create a failure scenario, or go so far above the requirements and not get failures that I'm sure I'm going to be compliant when the qualification test comes about? These ESS tests have been used successfully by many people for many years to aggressively find a model where a day or two of ESS can substitute for 3 weeks of finding a problem through the normal qual. It doesn't replace the qualification tests, but it can give identification of problems before they get there. Consider those tests that are not specified. As I discussed earlier, maybe an acid solution instead of a salt solution for that kind of a corrosive environment. Additional tests, they may be there if indicated. A fluid contamination when it's not an identified fluid, but you know it's coming to reality for your problems. Products that get to the field that have high failure rates or performance issues in a normal environment or a stressed environment really impair the sales, cause warranty claims, smear the reputation of the vendor. Has anybody ever heard of a vendor being blacklisted for lack of quality products? It has happened many times. They can't get a contract. Maybe not formally blacklisted, but they never get considered. The history is broad spread through the use of their products. I've seen it many, many times. Don't use an XYZ, use this one instead. It happens through word of mouth, and it's devastating to a manufacturer who builds products, and especially if they allow it to get through the evaluation period. Use the test and evaluation goal to identify and resolve the issues that contribute to an inferior product. Don't let it become to haunt you after the fact. That concludes my discussion. Do you have have you received any questions, Melinda?
Great. Thank you so much, Steve. We'd like to have a call for final questions. Please enter any last questions you may have in the navigation pane. We've received quite a few inquiries on where to get additional information on this topic. There's a vast amount of content found on our website, www.environmentaltestanddesign.com. You can also email us at info@etdnews.com with specific needs, and we can direct you accordingly. Steve, here's a question for you. You mentioned ESS testing. What standard defines ESS requirements?
Well, I don't know of one. There's a lot of development programs that are generally used, but I don't see it called out in a specific standard. A contract may define an ESS test as being, some extremes or vibration and temperature together or various things that can cause stress screening. But a defined program, not so much. I do find that during the engineering, if they're using ESS to go there, almost all the people I've worked with use a temperature vibration system screening to get extreme temperatures while it's being moved and shook. It tends to cause the breakdown of various things, and you can take them to higher than normal vibration and higher or lower than normal temperatures, and can force failure modes that you can analyze and understand that you may be able to make your design more robust. There's been several articles prepared. I have one that I tend to suggest when people ask me a profile, but it's not in a rock solid form as a standard to my knowledge.
Okay. You stated that temperature stabilization was not defined. Since immersion was called out, is there a good way to determine if the internal temperature has stabilized?
You said immersion is a good way to know if the internal. There's not a real good way other than time. And you can do this through before it's designed, during the engineering phase, look at the various masses before the unit's sealed, be able to get some temperature work and let that define the stabilization time. That's the preferred way, but that has to be done during the engineering phase before the unit comes into qual when it's sealed. Be the logical way I could conceive. Okay?
Okay, one more. Do you obtain the life cycle profile as part of the RFP?
Never have. Been doing this for that many years, and I don't recall seeing it. The statement of work that's very detailed probably has it behind that detail. Where they don't provide it, it's embedded. But as far as a document that says this is a life cycle profile, I've never had them delivered to me as a contractor in any of my work that I was aware of. Good.
Okay. Steve, thank you again for your time and expertise. Webinar attendees, if you have any more questions that we didn't answer here, please send us an email at info@etdnews.com. A recording and download of this webinar will be available on our website, environmentaltestanddesign.com. We will also send a link to all participants shortly. Thank you for attending.